Okay, let's take one more look as we venture through writing equations from representation of data. What we want to look at is, again, hypothetical situation and tell whether the number of juniors at our local high school actually compare the local number of juniors at our local high school to the total number of students. Now, let's say, again, let's describe it. X, Y. Remember, we're going to do the change in Y divided by the change in X. Well, 100 students, and out of that we had 25 juniors. 200 students, out of that 50. 300, out of that 75. 400, and out of that 100. So we need to go to work and see, can we find an expression or rule. So even though these numbers are large, we're talking about positions. We're talking about positions numbers still. So let's go here and subtract 100 from 200, and we will get 100. Let's subtract 2 from 3, we will get 100, and 3 from 4, and we will get 100. Okay, so some student number there, we don't know. Okay, so let's subtract the number of juniors. 25 from 50 is 25. 50 from 75 is 25. 75 from 100 also is 25. Now, let's be very careful how we look at this. We are easily to say, okay, we've been putting a big number on top all the time, so now we're putting a big number. We're looking at the change in Y over the change in X. So this would give us 25 over 100. 25 over 100. Why? Because 25 is Y, 100 is X. Now, what we have not done is came up with a unit rate. So I know you're going to say, well, wait, Mr. Taylor. In order for us to get a unit rate, then we are going to have to divide by 100. Okay, so if we divide 100 into 0.25, so we got 25, I'm sorry, almost gave away the answer, divided by 100, we would get 0.25. Okay, that's our rate. Even though it's going to be over 1, but that's our rate, so we have to go on and live with it. So if that's the case, now we need to see what type of rule can we come up with. What type of rule can we come up with where we're going to take 0.25 and literally get 25? I want to show you this two ways, because there's two ways we can attack this. First thing we can do is say 0.25n. Okay, what this will give us is 0.25 times 100, and when you multiply that, you will get 25. And you can keep going with this rule. So I'm going to put me a line here, because I want you to know that there are definitely two ways that we could solve that. Okay, so we got two different rules. So we can do 0.25 in all the way down. And of course, let me go ahead and take these ends and put the thing back in proportion. So this would be times 100. This would be times 200. This would be 0.25 times 300, and it's going to give me what I'm looking for, 0.25 times 400. Okay, another way we could attack this with this rule is reducing this particular fraction. So if we reduced 25 over 100, we will get 1 over 4. Now we can take that same rule, which is 1 over 4, and say, now let's divide 100 by 4. Okay, which is the same thing as dividing. So that my second rule here, I said 0.25 times n. This rule I can use as n divided by 4, or n over 4. So again, that'll give me 25, and then 200 divided by 4 will give me 50. 300 divided by 4 give me 75, and 400 divided by 4 will give me 1,000. So now we've come up with our particular rule, and either way we look at it, these rules are definitely going to fit. Either whether we multiply, because dividing by a fraction is the same thing as multiplying. So by dividing is, remember the reciprocal part, which is the same as 4 over 1. Okay, so now let's take a look at a hypothetical question. The school grown. I mean, it is grown leaps and bounds. So this year they expect 1,000 students. So this year the school expect 1,000 students. Now, how many will be juniors? So what we need to do, we need to write an equation. We got the rule, so either one. Okay, so let's write our equation. We definitely know how many students, so let's use the first equation. Let's use 0.25 n is equal to, we don't know. So we'll just put J for juniors. We don't know how many is going to be junior. We know it's going to be 1,000 students. So 0.25 times 1,000 should equal to J. And all we got to do now is multiply 1,000 times 0.25. Okay? That says, and the only thing you're doing now is multiplying times 1, adding 1, 2, 3, and then I'll show you how that works. So we got 0.25 times 1,000, 0, 0, 0, 5, 2, and we're pointing off 2 places. That'll give me 250 is equal to the amount of juniors they expect. So that's the first way. Well, let's take a look at that second one, because we put 2 rules in there which we know means the same. So here Now all I got to do is use this rule, which is n divided by 4 equal to the amount of juniors. Replace n with 1,000 divided by 4 is equal to j, and then go over here and 1,000 into 4, and that's 2, that's 8, that's 2 and 0, and of course that's 5 times 4 is 20, that's 20. Bring down the last 0, and we got 250. So again, 250 would be how many juniors we have. So, saying that, there are, again, myriads of ways for us to write this representation of write these equations from this representation of data. We just need to make sure that we are diligent with what our steps are to be able to break it down and then come back and apply it to some situation. All right. I will see you soon.